Hey guys, welcome to the test taking strategies day here at the ACT prep class. Thank you all for showing up and hope you guys get some good stuff out of it. This is one of the most important things you guys can learn from me probably are these test taking strategies that I'm about to go over. So this is something you definitely want to practice before you take the test. So be really aware of that. All right, first thing, we're going to go talk about some really fundamental ideas about taking the test. Obviously, the night before, get a good night's rest. You want to make sure your brain has fully gotten, as much sleep as you can get, 6 to 8 hours at least. I mean, I would really make sure you get a good night's rest. Next thing is breakfast. Make sure you eat something. Your brain needs carbohydrates to function, so you've got to eat something for breakfast. Orange juice, coffee, whatever you drink in the morning is fine. Also, maybe drink a little bit of water, not too much. You don't want to be, having to use the bathroom while you're in the test, but just make sure you get some kind of food in you. All right, now to more of like test taking strategies. That's kind of pre-test strategy there. Test taking strategy. So, I know you've heard this a million times, but just reminding you, if you get stuck on a problem, okay, don't sit there and struggle. Just move on. Now, some people prefer to actually fill in the bubble right there and move on. Some people wait till the end to fill in all the bubbles for the ones they're going to have to guess on. I personally think it's good just to fill in the bubble. You can go back and change it. Just make sure you circle the problem or something on the test booklet so that you can go back. You got to go back and fix those problems. But at least if you have something in there when time runs out and you got to put your pencil down, at least you'll have something in there. All right, on to some math-specific strategies, specifically for the math test. First one we're going to go over is guess and check. Okay, so anytime we're solving an equation, right, let's say 3x plus 7 equals 20. Okay. Let's make it 3x plus 8 equals 20, just for simplicity's sake. Okay, 3x plus 8 equals 20. So you've got all your choices here. They're usually going to be in order from smallest to largest. Let's see. All right, so you could just guess and check. You could plug in 0 for x, right? And if you do that, you'll get 3 times 0, okay, plus 8 equals 20. And the goal is to see if this thing is the same as this thing. The left side is the same as the right side. So when you test it out, you get 0 plus 8, because 3 times 0 is 8, should equal 20. Does 8 equal 20? The question is that true or false? That is false. So what that means is that everything we just did here showed us that this answer right here, 0, is false. Okay, so we know that that is not our solution. So next thing we're going to do is we're going to try 2. So same thing, right? 3 times 2 plus 8. Again, I'm just plugging in 2 in for the x. Okay, 3 times 2 plus 8 equals 20. We're going to see if this works. So 3 times 2 is 6. 6 plus 8, that's 14. Does that equal 20? No. So again, that tells us that 2 is not a valid solution. So we've ruled out 2 and we've ruled out 0. Next thing we're going to try is 4. Okay, we're going to add 8 to make sure it equals 20. So 3 times x, when x is 4, plus 8 equals 20. 3 times 4 is 12. Plus 8, that is 20. We get 20 equals 20. Now that's actually true. So what we know about that number 4 is that 4 is going to be our solution. It's our number that makes the equation true. Any number that makes the equation true, we call a solution. So that is what we're going to call guess and check. Again, we're not really solving the equation. That would probably actually be the best way to do that here. And usually, when you're working these kind of problems, doing it the way that you're kind of intended to is usually the best, but guess and check is like a fallback method. So it's a plan B. I didn't know what to do, so I just guessed and checked. I checked each answer and see which ones worked. Okay, So that's a valid strategy. Sometimes it's a really good way to do it, actually. So don't rule it out as something you might try. All right, so next thing I want to talk about is this same problem. Okay, 3x plus 8 equals 20. Now this time I'm going to switch up the answer choices. All right. All right. Now, remember, last time when we worked this problem, we started with guessing A, and then we guessed B, and then we guessed C, and then we guessed D, and then we guessed E. This problem is actually, obviously we know the answer is 4, but this problem, as far as probability goes, the best probability of getting this thing done the fastest is to actually guess C first. Okay, I know it seems like it shouldn't matter, but I'll show you why. If you guess C, right, and you plug it in, 3 times 6 plus 8 equals 20, and you notice that this does not equal 20 because you get 18 plus 8, and that's definitely not 20. So we know this is not a solution. But what I do know is that I got, 26 is equal to 20. So when I plugged in 6 here, my number was that I got here, 26, was too big. Okay, so that means that that number 6 that I was trying to use was too big. So what actually happened here is I can actually eliminate 3 choices. It can't be D and it can't be E as well, because those numbers will only make this number 26 bigger, which makes it further away from 20. Okay, so a lot of times when you're doing guess and check, if it's in order from smallest to largest, like our answer choices are, you actually want to start with the middle choice, because with only guessing 1 time, I eliminated 3 choices. That's much better than eliminating 1 choice each time. That takes too long, okay? So the next thing we would do is say, okay, so it's got to be smaller than 6, so then it doesn't matter which one you pick. Let's pick 5, okay? We'll try to solve it with 5. So if I plug in 5, I get 3 times 5 plus 8 equals 20. I get 15 plus 8, that's 23. Does that equal 20? No. Which tells me that, again, that number's too big, so it's not 5. That means the only choice is answer A. Okay, but if you really think about it, right, how many times did I have to guess and check here to ensure that I knew the answer? I only had to do it twice. So this strategy of picking the middle number, okay, is always going to be your best bet, as long as they're in order, okay? And as long as when you plug it in, you can kind of tell. Sometimes it doesn't quite work out that way, but it's still a fine strategy to use if you're going to guess and check anyway. Just guess the middle number and then either go up or down depending on if you need a bigger or smaller number. All right, remember this is for when we're solving equations. How do you know something is an equation? Well, there's a left side, an equal side, and there's a right side. Okay, it's got to have 2 sides with an equal sign in the middle. So this has a left side, 3x plus 8. It has a right side, and it has an equal sign in the middle. That's how I knew it was an equation. We're going to talk about some expressions in a few minutes, and you're going to have to be able to tell the difference between an equation and an expression. All right, so if you're working, let's say, a quadratic, ax squared minus 3x minus 10 equals 0. Okay, and it has, what are the solutions, or what are the roots, or what are the zeros? There's lots of ways they could say it, but they could have some things like this: x equals 3, x equals 2, right? X equals negative 3, x equals 2, x equals 4, x equals 2, x equals negative 5, x equals 2, and x equals negative 5, x equals negative 2. Okay, so in other words, there's 2 answers to this quadratic solving solution. When you solve this, excuse me, I should say, when you solve this, you get 2 solutions, 2 answers. So there's an x equals this and x equals that. So what's a good place to start here? I would always start with common numbers. So you see how there are a lot of 2's, okay? So if you pick 2 as your solution and you plug it in, right? Again, we're doing guess and check. When you plug that in and you get 2 squared minus 3 times 2 minus 10, and we see if that equals 0. If it works, you've eliminated choice number E. Okay, you can say, okay, it's not E. If it does work, or excuse me, if it doesn't work, then you've eliminated 4 choices. So it can't be any of these 4. Then you know your answer. So testing 2 is a good strategy because it helps eliminate several things. What would be another good number to test? Well, you could test, let's see, I see -5 appearing a couple times, right? So that's a good one to test, because if -5 does work when you're guessing and checking, then you know that it's one of these 2 solutions here. If it doesn't work, then you know it's not one of these 2, so there's only 3 choices remaining. So again, you want to pick numbers that are going to help you eliminate things, okay? So just make sure you're choosing those things wisely. All right, moving on. So the next thing we're going to talk about is a strategy called picking a number, okay? This strategy definitely helps, all right? So this strategy is called pick a number. Okay, it is really helpful, especially, it's helpful in lots of ways, but especially when you're doing a percent or a fraction problem where they don't give you the starting number. Okay, they don't give you the starting number. So like they don't tell you how much you start with. Okay. So the idea is, Samantha gives half of her money to charity. All right, then gives a fifth of her money that's remaining to charity. Then she gives a fourth of whatever's left to charity. How much does she have left? Okay, but they'll ask it like, what percent of the original does she have left? Or what fraction of the original does she have left? So again, you don't know how much she starts with, okay? So if you don't know how much she starts with, it usually means that it doesn't matter how much she starts with. She can start with 1,000 or 100 or $1 or whatever. The number I'm going to coach you on is you're going to pick the number 100. Okay, if it's a fraction or a percent problem and they don't tell you how much you start with, go ahead and assume that they start with $100. Okay, and I'll show you why this is important. All right, so Samantha gives half of her money to charity. Well, half of 100 is 50, so she spends 50 to charity. She's going to have 50 remaining. Okay, so bam, now she's got 50. Then she gives 1/5 of that. So break that up into 5 pieces. That's $10 per piece, and I'm going to give away 1/5. So one of those pieces. So she's going to give away 10. Again, that gets you down to 40. Then she gives a fourth of her money away to charity. So a fourth of what's left, break that into 4 pieces. Each piece is 10. So one of those pieces is 10. So if she gives away 1/4, she gives away 1/10. So she'll have $30 left. Okay, so she started with 100, ends up with 30. Okay, what percent does she have left? This is the easiest problem in the world. Percent means out of 100. Well, if she starts with 100 and she ends up with 30, then she has 30% left. That's why we like picking 100, because when you get to the end, your answer is the percentage. So what fraction? Well, you'd have to do the part over the whole. So 30 out of the 100 she started with, but that's pretty easy to remember that that is 3/10. Okay. All right. So if it's a fraction problem, you do part over the whole. So whatever part was left over the whole that you started with. If it's not a fraction problem, if it's a percent problem, then your number that you get at the end is your percentage. So it's really easy to do. All right. So we were talking about expressions versus equations. So let's review that one more time. Okay. So an expression is just one side of an equation. An equation has two sides, and in the middle of those two sides, there's a equal sign. So an expression usually we say doesn't have an equal sign, but you got to be careful. On the ACT, you will see equal signs sometimes. You'll see it right next to the expression. And so a lot of people are used to in school hearing things like, oh, an equation has an equal sign, expressions don't. So you got to be careful that an expression can have an equal sign. It just won't have anything over there on the right side. So an example of an equation is x squared minus 10 equals 3, right? Here's your left side, here's your right side, there's your equal sign right in the middle. Right? An expression would be something like x squared minus x, and maybe you have an equal sign in there as well, okay? So that's very possible that you may see something like that, okay? Now here's an example that trips people up sometimes, is this example. X plus 10 equals 0, all right? Does it have a right side? That's the question. It's got a 0, which isn't anything. So does that count as a right side? We're going to count that as a right side. Okay, if you see 0, if you see anything, right here there's just a blank spot. That's nothingness. 0 is something. Okay, it's a number. So in this case, we're going to call this an equation. So this fits over onto the right side of equations. All right? So now that you know the difference between equations and expressions, we're going to learn a really, really, really good strategy here. All right? This strategy is going to help us simplify an expression. All right? So before we get into the actual strategy, I want to just show you something here. All right? Here's two different expressions, 2x and 4x divided by 0. Okay? So if we let x equal 0, okay, if we let x equal 0, what is the value of the expression 2x? Well, if x is 0, 2 times x, which is really 2 times 0, that's going to be 0. So the value here is 0, right? When I plug in x equals 0, what I'm doing is just 2 times x, and I get 0, okay? All right, so what about 4 times x divided by 2, right? What about this expression here? Well, 4x divided by 2, if x is 0, 4 times 0 is 0 divided by 2, that's just still 0. Okay, let's try another one. Let's let x equal 1. Okay, what's the value of 2x? 2 times x. So 2 times 1, that is going to be 2. And what's this expression over here? 4 times 1 over 2. That's 4 times 1 is 4. Divided by 2, that is 2. So 4 divided by 2, just 2, okay? What if x was equal to negative 10, okay? Well, 2 times negative 10 would be negative 20, right? Positive times a negative. On the other side, 4 times negative 10 is negative 40, but if we divide that by 2, I get negative 20, okay? No matter what number I pick for x here, doesn't matter what I pick, what I get for 2x will be the same thing I get for 4x squared. Okay, no matter what I pick. So this is because 4x is equivalent to 4x divided by 2. They're equivalent. So this is a key word, equivalent. You're going to see this, and I'm going to show you the other keywords that you'll see. But this is equivalent for any x that I choose. Okay, so that's one way to see why this strategy works. All right, so let's use this strategy. All right. 3x squared plus 2x. Okay, maybe it says simplify. All right, that's another keyword. If you see the word simplify, or if you see the word equivalent to, right? These are our trigger words. We're going to see equivalent to and simplify. These are the words that remind me, okay, I should do this strategy. Okay. So we're going to try to simplify 3x squared plus 2x. Now, we're not going to do it the way that we're supposed to do it. We're going to do it in an alternative way. Now, the way you're supposed to do it is great, right? Factor out that common factor x. That is the fastest way to do this problem. All right? But we're gonna be practicing this strategy. So note one thing, this is an expression, okay? This strategy works for expressions. So here's our answer choices, right? Maybe we get 3 x to the third Maybe we get 6x to the third, 6x squared plus 6x, and then x times 3x plus 2x, and then x times 3x plus 2. Okay, so what we're going to do is we're going to let x equal 0. Okay, what we're going to do is we're going to plug that in up here and see what the value of that expression is. So it's really, really clear to see 3 times 0 squared, that's 0, plus 2 times 0, that's 0. So 0 plus 0 makes 0. So we get 0 when we do this. Okay, I'm going to put that in a box because that's the value we're going to be looking for. That's our target. So when I plug in x equals 0 into the original expression, I get 0 as a value. So what I need to do is check all these other expressions. So I plug in a 0 here. 3 times 0 to the third power. Well, 0 to the third power is 0, and 0 times 3 is 0. So it could be A. So A is still a possible answer right now. If I plug it into B, for x, I get 6 times 0 to the third. That's still 0. Okay. I plug in 0 here. I get 6 times 0 squared. Well, that's 0. Plus 6 times 0, that's still 0. So 0 plus 0, that's 0 all around. Okay. On the next two, they're really quick and easy to check because when x is 0, you have 0 times something. It doesn't even matter what these things are. 0 times anything is 0. So unfortunately, with this example, testing 0 didn't actually help eliminate any choices. Okay, but it's okay. This is just what we're going to do. We're going to try x equals 0 and see what it eliminates. The next thing we're going to test is x equal 1. Now we plug in 1 for everything. Now 1 is still really easy to find the value of here. 3 times 1 squared. Now remember, you got to square the 1 first. So 1 squared, that means 1 times 1, that's 1. Then you multiply it by the 3. So it's 3 times 1, that is 3, plus 2 times 1. 2 times 1 is 2. So the value of that expression is 5. Okay? When x equals 1, the value of that expression is 5. So what we're going to do is we're going to plug in 1 for all the other ones and see if we get any matches. We have to be 5, otherwise it's not going to be possible for that answer to be a solution. So we plug in 1 for x, we get 3 times 1 to the third. Remember to do 1 to the third first. So 1 to the third is 1, because 1 times 1 times 1 is 1. Times 3 is 3. Now you're going to notice pretty quickly that this number in front, this coefficient, is going to be the value of that thing when x is 1. So when x is 1, this is 3. Does 3 match the 5 that we're supposed to get? No, which tells me that A is not a possible answer. Because when we plugged in 1 into that expression, we didn't get 5. Let's try it here. Pretty quickly, you're going to see that 6 times 1 to the third is just 6. So it can't be B because our answer is supposed to be 5. Okay, let's try C. 6 times 1 squared, that's 6. Plus 6 times 1, that's 6. 6 plus 6 is 12. It's not equal to 5, which tells me that C cannot be my answer. Okay, D, 1 times 3 plus 2. That's 1 times 5, that's 5. That matches what we got earlier. So D is still a possibility. We haven't ruled out D yet. We still have E, so we're going to check E. Okay, so we're going to check E. We're going to plug in 1 times, let's see, 3 times 1 is 3, plus 2, that's 5, right? Do the parentheses first, order of operations. 3 plus 2 is 5, times 1 is 5. So E is also a possibility. So we've narrowed it down to 2 choices, D or E. So we tested 0. 0 actually didn't help us out any. We tested 1, and 1 narrowed it down, right? 1 got us to where it was either between 2 choices. So that was awesome. So now that we've tested 0 and 1, now we're going to test 2. All right? Now remember, we only have 2 possible choices left. We've already eliminated A, B, and C. So let's plug in 2. Well, plug it into the original, the question. So 3 times 2 squared, 3 times 2 squared plus 2 times 2. Well, 2 squared is 4. 4 times 3 is 12. Right? 4 times 3 is 12. Plus 4. That makes 16. So that's our target. We're going to try to make sure one of D or E is going to be 16 and one of them won't be. If either of them are not 16, we can eliminate that choice. So let's try it. D, 2 times 3 times 2. 3 times 2 is 6. Plus 2 times 2 is 4. So remember, do the parentheses first. 6 plus 4 is 10. And 10 times 2 is 20, which does not match our 16. So I can eliminate D. Can't be D. So my only choice is E. Now, if you want, you can check it. 2 times 3 times 2 plus 2. All right, 3 times 2 is 6, plus 2 is 8, and 8 times 2 is 16. So this strategy helped us eliminate those choices A, B, C, and D, and leave us with E. Now, obviously, all right, 3x squared plus 2x is fastest if you recognize that both of these terms have a common factor of x. So you factor it out, right, which leaves you with 3x plus 2. We factor it, we get our answer much faster than the other way. But this is the strategy for if you're unsure of how to do a problem, you can fall back on this. This is your plan B, okay? So it's really important that you know how to do this, even though it may not be your first choice of the strategy. All right, let's look at another example. This one involves multiple variables. So x times y plus x divided by x. And maybe it says is equivalent to, right? Remember, that's one of our keywords. If it's equivalent to, I know it's an expression, and I know I'm supposed to simplify the expression. So first of all, try to do this the way that you think you should do it. Like, well, I'll show you how to do it at the end. But if you know how to do this problem, it's really, really quick. But this, again, is for those times when you just kind of forget or just not sure what to do, and you need something to work with, okay? So here's our choices, all right? X, Y, or x plus y, all right? X plus 1, y plus 1, and xy plus 1. Okay, here's our 5 choices. So again, just reinforcing this, this is an expression. It's not an equation, okay? This is our strategy for solving expressions, or I should say simplifying expressions. So we're going to try x equals 0, all right? Except for we're not allowed to use x equals 0. Do you guys see why? It has to do with the bottom of this fraction. If I plug in x equals 0, I'm going to be dividing by 0, which you're never, never, never allowed to do. So instead of 0 for x, I'm actually going to let x be 1. Okay? So I'm going to let x equal 1. Now I've got another variable in there, so I need to assign it a value. I always like to pick y equals 0. So let one of them be 1 and the other one be 0. Okay? So let's plug this into the original. I get x times y plus x divided by x. Okay? I'm just taking this expression and I'm plugging in the values for x and y that I chose. So that's what gives me this right here. All right? So when I simplify that, I get 0, right? 0 plus 1, which is 1, divided by 1 gives me 1. So there's my target. Okay? So plug in x equals 1 and y equals 0 into here. You'll see that that is equal to 0, right? 1 times 0 is 0. So what that tells me is it can't be A. I get to cross it off. It's not equal to 1. All right, next one, x plus y. Well, 0 plus 1 is 1, so I'm going to say that's a possibility. The next one, C, 1 plus 1 is 2. Right? If x is 1, then 1 plus 1 is 2, and that's not equal to 1, so I can eliminate that one. D, y plus 1, y is 0, so 0 plus 1 is 1. So I can say, oh, that's possible. All right, the next one, x times y, which is 0, plus 1 is 1. So I'm going to say that's a possibility as well. All right, so first time I tried my x equals 1 and y equals 0, I eliminated 2 choices. That's great. All right, now we're going to switch them. So now we're going to try y equals, or excuse me, we're going to say x equals, oh, we can't have x equals 0, sorry. So x equals 1 and y equals 1. This is another good choice. Remember, you can kind of pick anything you want. I just like picking small numbers because I can do them in my head. If you're going to use your calculator, actually, you can pick like crazy numbers, like x equals 10 and y equals 50. And then as long as you get the same thing, like if you use crazy numbers, you won't be able to do it in your head necessarily, but you'll be able to get the answer first time. So that's not a bad strategy, especially if you're using your calculator. So remember that as well, that I'm choosing small numbers that I can do in my head, but you could pick bigger numbers that are going to guarantee you an answer quicker. So that's another way to think about this. All right, so y equals 1 and x equals 1. So what's the value of, first of all, the original? Okay, so the value of the original, all right, is going to be, when x is 1 and y is 1, all right, it's going to be 1 times 1 plus 1 over 1. Well, 1 times 1 is 1, plus 1 is 2, 2 divided by 1 is 2. So we're targeting 2 here. So when I plug in x plus y for 1 and 1, I get 2. So that means B could still be an answer. When I plug it in for D, I still get that, I still get a 2, because 1 plus 1 is 2. Even on E, 1 times 1 is 1, plus 1 is 2. So again, that one didn't really help me much. So that strategy of picking that one didn't help me, but that's okay. All right, now we're going to try x equals 2, and we'll do y equals 2. All right, really you can kind of pick anything here. There's no right way to pick these numbers. I'm just picking smaller ones because they're easy to work with. So let's plug this into our original. 2 times 2 plus 2 divided by 2. All right, that's x times y plus x divided by x. If I simplify that, I get 4 plus 2. 4 plus 2 is 6. And then when I divide that by 2, I get 3. Okay? Now let's look here at B. X plus y. Well, 2 plus 2 is 4, which doesn't equal what I was looking to get. So I can say B is not correct. Can't be B. All right, looking at D. D says that 2 plus 1, because y is 2, 2 plus 1 is 3. So it could be D. And then if I look at E, x times y, that's 2 times 2, which is 4, plus 1 makes 5. So it cannot be E. So we're going with our choice D. All right, so that strategy again, just to remind you, is to solve simplify an expression, or find out what another expression is equivalent to. Now, just a reminder, that's not your best strategy, right? What you should try to do here is say, oh, look, the top factors into x times y plus 1 over x. Now I can cancel since there's no more plus signs, so I get y plus 1, which is exactly what we got just a minute ago. Right, we got y plus 1 as our answer, but this strategy is a little faster. Again, we're using this in worst case scenario, like if we're just not sure what to do, we're going to use this example. All right, so on to equations. All right, this time we're going to use our graphing calculator and to show how to do this. So let's see here. Sorry, I've got to switch this over. So you can see my desktop. All right, so here's our graphing calculator. All right, this is just like any other TI-84. You're just able to see what I type in and all those things. So if I want to solve an equation this time, okay, so I want to solve an equation, let's say 7x minus 3 equals, so I don't know if I can put an equal sign here. Just pretend that's an equal sign, equals 10. Okay, so we're pretending that this is an equation, 7x minus 3 equals 10. So this is the strategy for finding the solution to any equation. Any equation you can solve using this strategy, okay? So what you do is you set the left side of the equation equal to the right side. So the left side of my equation right now is 7x minus 3. So I'm going to graph that, okay? I'm going to graph 7x minus 3. 7x minus 3. Oops. Sorry. 7x. I'm going to clear this off. 7x minus 3. That's your left side of your equation, okay? Now you go down, for the right side of your equation, you put in the right side. So 7x minus 3 equals 10. Graph the left side on the top, the right side on the bottom. Then I hit graph. Okay, there's my two equations. Now, you got to be careful. You got to know how to use your zoom on this, because a lot of the times you won't see both of the lines. So you got to know how zoom works. So if you hit the zoom button, zoom 6 is zoom standard. That gets you back to your original. If you ever get your zoom out of whack, zoom standard. All right, zoom, if I hit up and go from the bottom, zoom fit is kind of good sometimes. It doesn't always work. But if I hit zoom fit, there we go. For this one, it worked great. It puts it right in the middle where I can see the intersection, okay? If zoom fit doesn't work, then you're gonna have to adjust your window. So remember, the X minimum and the X maximum is like the left and the right sides of your window. So you see how I've got this little window here where you're looking at me right now? The right side is your X maximum. The left side is your X minimum. So if you need to see further to the right, what you have to do is you have to adjust your X maximum. You need to make it bigger, okay? So you come down here, you make your X max bigger, then you graph it, you'll see now more to the right, okay? Now let's say you need to see more down, like I need to see more of what's at the bottom of my picture. Well, remember, up and down, think about the vertical y-axis, that's the y-axis. So you need to see smaller y numbers, that's your y minimum, that's what's down here. So you need to decrease your y minimum. So normally your y minimum is negative 10. Right now it's at negative 73, but if I need to see more of the downward side of my my window, I need to make this smaller. So maybe negative 1,000, right? Maybe that's what I need to see. So after I change that to negative 1,000, and I hit graph, then now, let's see, it's not working. I don't know why. Maybe it's, maybe I'm not hitting enter. Negative 1,000. All right, so it didn't like that for whatever reason. I'm not sure why it didn't like that, but that's okay. Oh, I was probably using the wrong, I was using my keyboard. I should have been using the negative sign. I bet I used the wrong negative sign, negative 1,000. Here we go. All right, figuring this thing out. Now if I hit graph, now you can see a lot more of the bottom, okay? Now remember, if I want to ever go back, if I messed everything up and I want to go back, I hit zoom 6, that's zoom standard. So zoom 6 gets me back to the original. Okay, so what's our point here? We're solving an equation by graphing the left side and graphing the right side, okay? What I want to know is where do they intersect? See this little point right here? I'm assuming you can see my cursor. Where the blue line hits the red line, that's what we're looking for. Now I'm going to make the y maximum a little bit bigger, just so you can see it a little better. We're looking for that place where those two lines cross. That is going to be the solution to the equation. Okay. Now follow closely here on this key press history. This is really, really important. So the second function and trace. Right there in the blue, it says calculate. That's where a lot of these major functions are at. So if I hit second trace, okay, you're going to see I have all these options here. So we want to choose number 5, the intersection. So you can either go down to 5 and hit enter, or really I like to just hit the number 5 on there because it does it automatically for me. Now it's saying what curve is the first curve. If I hit up or down, it's going to bounce between the top line and the bottom line. Okay. Now this is a dumb question when there's only 2 graphs because it doesn't matter which one is the first one, which one is the second one. So really you just hit enter, and then which one's the second one, it'll go to the other one, you hit enter, and then it says guess. Now when they only intersect one time, you don't have to really guess, but I'll just show you how to do it here, okay? You kind of scoot over here and then get close as you can and hit enter. That's important. If it hits twice, you'll need to actually do this process. If the 2 lines intersect twice, like if one's a curve and one's a straight line, you'll have to do this process. But then I hit enter, and then it gives me this intersection is x equals 1.8571429, y equals 10. Okay? So I don't care about the y number. I really only care about the x number. Okay? So think about 7 times 1.857 blah, 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 minus 3 equals 10. So the number that solves the equation is the x number. Do not worry about the y number when you're doing this, okay? Just use the x number. And again, this works for any equation. If I want to solve a quadratic, okay, maybe I've got x squared minus 3x minus 10. This is kind of our example from earlier, equals 0, okay? Well, the left side is x squared minus 3x minus 10. The right side is 0. So I hit 0, and then I graph the two, okay? Now, you see where they hit twice? One here, one here. Now, if you're not using a plus C, TI-84 plus C, you're not going to see this in color. This red line will be almost invisible. You won't really see it. So you really have to just remember that it's there when you have equals 0. So this second part here, the red line, see how it's y equals 0? Just got to remember y equals 0 is this horizontal line. So we're going to solve this equation, x squared minus 3x minus 10 equals 0, by graphing it, okay? Graph the left side, graph the right side, then find the intersection. So let's see how we do that again. All right, second, calculate, right? That's the trace button is the second function of the trace button is calculate. Which number? Number 5. So go down to number 5. This time I'll show you how to go down and hit enter. All right, so now first curve, second curve. Again, first curve, second curve doesn't really matter. All right, we'll pick the blue one as the first one, and we'll pick the red one as the second one. Now the guess here, I actually do want to go over and hit enter. X equals -2. That's one of the solutions to this equation, okay? Now if I do it again, second, calculate, number 5, the intersection. First curve, second curve, so enter, enter. Now guess, I have to go all the way back over here, and I hit enter again. X equals 5. Now these were easy to see. You could kind of tell that this crossed exactly at 2 and this crossed exactly at 5. If you were looking at your answers and they weren't like weird decimals or fractions, you could probably figure out that it was -2 and 5 without actually having to go through this process. But again, the point is that you're realizing you can solve any equation by graphing the left side of the equation, graphing the right side of the equation, then finding the intersection of the two. Okay? Now this is something you definitely want to practice. This is not something that you're going to just be like, oh yeah, this is easy, right? I mean, it may be something you've worked with before, but even then, I would work on this, I would practice, I would get faster, I would get more comfortable with this strategy. I would definitely put in some time on this because I think this is big. It helps you solve any equation. Doesn't matter what the equation is, you can solve it like this, okay? All right, so last thing we're going to talk about for today is inequalities. So sorry I have to do this. It's going to take me just 5 seconds. 5, 4, 3, 2, 1, maybe 6 seconds. All right, here we go. All right, so here we go. We're going to look at inequalities. All right, so there's a couple different things with inequalities. First off, they could have you solve an inequality. So they might give you something like 3 times x minus 6 is greater than 10 times 5 minus 2x, right? Something like that. Now, I would just solve this. If you're comfortable with inequalities, just solve it. Don't forget that when you solve this, that if you divide by a negative or multiply by a negative, you have to flip the sign around, okay? The less than will become a greater than. Anytime you multiply or divide by a negative number, you've got to do that, okay? But I'm going to show you kind of with this testing strategy, this pick a number idea, okay? So you can kind of, all right, so the answers are going to look like this, okay? Oops. Your answers are either going to be graphs, where they've got, you know, sections of it shaded in. And if that's the case, right, we're working on this pick a number strategy. Pick a number on here, like say 4, or excuse me, -4, okay? Let's say -4 is here and -4 is here. You see how -4 is not a solution because it's not in the shaded region, but over here it is in the shaded region? -4 is a number we can test. and kind of help see what makes sense. So we want to know, is -4 a solution to the original equation? Well, we plug it in. 3 times -4 minus 6 is greater than 10 times 5 minus 2 times -4. Okay, you get 3 times -4 minus 6 is -10, is greater than 10 times 5 minus 2 times -4. That's 2 negatives being multiplied. That makes a positive 8. So you get -30 is greater than, remember this is 13, that's 130. Is it true that -30 is greater than 130? No. That means that number we tried to plug in, -4, is not a solution. So -4 is not a solution. So we want to go with the graph where -4 is not a solution. So we do not want to choose the bottom one because -4 appears to be a solution in that. So we're going to say, oh, -4 is not a solution. That makes it look like more like this graph. Okay, so again, we're using that pick a number strategy to help eliminate some choices. Okay, sort of in the same line. Okay, your answers don't have to be graphs. They could be what it would be like if we solved this thing. So it could say something like, let's see here. X is less than or equal to -12. X is greater than or equal to -12. X is less than or equal to 12, or X is greater than or equal to -12. Okay? So one quick thing. If it's less than or equal to -12 or 12, that 12 is going to be on the border. So that means when you solve this thing, it's going to be the last point of no return. So if you try checking -12, 3 times -12 minus 6, less than or equal to 18, you get -18 times 3, -48 is less than. It is true, but you see how these numbers aren't equal to each other? That means it's not on the border. So -12 is not like on the very tip of the solution set. What about 12? 3 times 12 minus 6, that's less than or equal to 18. You get 6 times 3, you get 18 is less than or equal to 18. That's the point of no return, right? When I plug in 12, it's like it's the last number that works. Anything, and we're not sure which direction, but if I look at it, 12 is the point of no return. So it's this last point. So I'm either going to shade this to the right, or I'm going to shade this thing to the left. Now, how can I tell? Well, it's either less than 12, or I'm going to erase this little negative symbol because I did not mean to put it, or it's X is greater than or equal to 12. We'll just test a point. Okay? Test the point 0. I like 0. It's really, really easy to work with. Okay? When I plug in 0 into this inequality up here at the top, I get 3 times 0 minus 6, that's -6. So 3 times -6 is less than or equal to 18. 3 times -6 is -18. Is -18 less than 18? Sure is. Which tells me that my solution set is everything less than 12. Okay? So the strategy here is to kind of, if you can look at these solution sets and go, oh, if I pick this number, I could eliminate these two equations. Or if I pick this number, I could eliminate this equation. Your goal here is to find numbers that when you test them into the original, right, this one up here, the original, when you test those numbers into the original, you can tell whether or not that number is a solution or not. And then you just match it with the answers that work. So this is just another example of that pick a number strategy. So just to review, all right, what we talked about today. We talked about expressions versus equations. Okay, and we talked about an expression is something where there's no left side. X squared plus 10 is equal to, right? Or there's a left side, but there's no right side. An equation is something more like x squared plus 10 is equal to 20, where there's a right side of the equation. Okay. Expressions, we worked on that strategy of letting x equal 0, then 1, then 2, and seeing how we can eliminate choices that don't work. Okay. You can do this with any expression. If it says simplify, remember that's one of our keywords. You see the word simplify this expression, and you can do this. If it says this expression is equivalent to, and then it leaves you with a bunch of choices, you can use this strategy. Okay. On the other side, we saw equations. We graph the left side, we graph the right side. So, we plug in this left side in, we get this graph here. That's for the left side. Then for the right side, we plugged it in, and we got this equation. And remember, our solution is going to be the point where they intersect. And again, x equals 5, y equals 1. One of those numbers we could care less about. We don't care about the y number. That number x is our solution. Okay? So again, this is a big time strategy. I hope this helps. If you have any questions, you can email me, Justin at tutoring-solutions. Gosh, I should brush through that. Solutions.com. Message me if you have any questions. And otherwise, good luck on your test. Make sure you get some rest. Eat something with carbohydrates in it. Piece of toast, some cereal, something, like light. You don't want to go into a food coma. Go into the, breakfast buffet. That's something I would do, but it's not something I recommend when you're taking a test. So anyway, good luck to you. I hope you guys do really well. I know you'll do great. You guys have put in a lot of hard work, and you guys should definitely be proud of yourselves. And way to go. All right. Thanks again. See you later.